Hello, in this video I'm going to solve the following problem for you. This is a problem on the topic of complex numbers basics. Let us read the problem. Let I be the imaginary unit. Consider the following complex number z equals to the sigma n goes from 0 to 50 I to the power of 2 n plus 1 factorial. What is the real part of z? That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do your calculations correctly, the answer that you will get is simply 48. Okay, now let us solve the problem here. Okay, first of all, if I want to know the real part and the imaginary part of a complex number, I have to simplify it and put it in a standard form, and then I will be able to read the real and the imaginary parts of my complex number. Okay, so what is the meaning of this sigma? So let us try to expand this sigma to have a better understanding of this sum. So I have to replace n with 0, then with 1, then with 2, up to 50, and then I will get 51 terms. Then I add them up, simplify them, and then I should be able to read the real and imaginary parts of my complex number. So let me just do that. If I replace n with 0, it becomes 1 factorial, so it becomes I to the power of 1 factorial. Let us keep it like that for the time being. The next one will be I to the power. If I replace n with 1, because you know that 2n plus 1 represents an odd number, so if I put 1, it becomes 2 plus 1, 3, so it becomes 3 factorial. And then I will have I to the power of 5 factorial. Yes, the next one will be I to the power of 7 factorial. And then if I continue this list, it becomes I to the power of, and I put 50, 2 times 50 plus 1, 101 factorials. Okay, but this is a very simple problem because high powers of I are fairly easy to calculate, yes? So for example, if the power is a multiple of 4, then the answer of that power of I becomes 1. Why is that? So let us say that I have a m, and I want to calculate I to power m. Let us assume that m is a positive integer. But let us also assume that m is a multiple of 4, saying that this is 4 times k, in which k is a positive integer. If I ask you then what is I to the power of m, so you would say this is I to the power of 4k, but I to the power of 4k can be viewed as I to the power of 2 to the power of 2k. I to the power of 2 is minus 1 by the definition of I, and then I have this to the power of 2k. When I say m is a multiple of 4, so it means k is an integer, so 2 times k is an even number, regardless of what the value of k is. And I have minus 1 to the power to an even power, so it becomes positive 1. So that is very important to realize that if your exponent is a multiple of 4, I to that exponent is equal to 1. But then what happens? 1 factorial is just 1. So I would write I to the power of 1, which is this one. But what is 3 factorial? 3 factorial means 1 times 2 times 3, which is 6, and it is still not a factor of 4. So let me just keep it as I to the power of 6. But 5 factorial, 7 factorial, up to 101 factorials are all multiples of 4, yes? Because in 5 factorial, you have 1 up to 5, so 4 appears. When I say that 7 factorial, oh sorry, this is not 7i, this is 7 factorial. If I say 7 factorial, I multiply every number from 1 up to 7. Of course, 4 is one of them. So it's a multiple of 4. The next factorial is a multiple of 4. All these factorials are multiple of 4. So then it becomes clear what to do. So I to the power of that number becomes 1. Because of that, the next one is also 1, and this list of 1s continues to the very end 1. Okay? So now I need to see how many 1s are there, And then I also need to calculate these two. So for example, I to the power of 6 can be written as I to the power of 2 to the power of 2, to the power of 3. And then I to the power of 2 is minus 1, to the power of 3 is just simply minus 1. So this one is minus 1. Yes? And this one is simply I itself. But how many ones are here? So I started from number 5, number 7, up to 101. So that is a arithmetic progression, 5, 7, 9, up to 101. The first term is 5. The common difference is 2. And I want to see how many numbers are there. So let us say that I don't know. Let us say that there are n terms there. So a number n is a number 1 plus n minus 1d. A number n is 100n, a number 1 is 5, n is missing yet, but d is 2. I move this to the other side, it becomes 96 is equal to 2 times n minus 1. I divide by 2, it becomes 48 is equal to n minus 1, so n is 49. Yes? So there are 49 ones. Okay, so the answer becomes now clear. So I will have I plus minus 1 plus 49 ones means 49. But 49 plus minus 1 is 48. And then I have I. So this is my complex number. And then you can immediately see that the real part is 48. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.